All right. Hey guys, thanks for joining. This is my first live stream, and I got so much stuff that I'd like to talk to you guys about that I figured this is probably the best format to do it in. Plus, I keep getting lots and lots of questions from people. They're writing me from all over the world, and I think we're going to set up a time where typically throughout the week, I'm going to resort to an hour, maybe 2 hours. We'll set up a live stream. I'll let you guys know in advance, and maybe I can answer some of these questions live, so this back and forth doesn't have to happen. But anyway, I've got so much stuff that I want to talk to you guys about. I brought this guy home with me. This is a Centrifuge, and it is not powering up. So I figure let's run you through the process of how I figure out what's going on with these devices and why I can troubleshoot so quickly. This is probably the perfect example. I mean, let's go ahead and get a power cord and try it out. Oh, what do I got? What do I got? This guy. This looks like a good power cord. If this is going to be my permanent workspace, I'll probably have power cord set up. But I do know in the field, this guy was due for a PM, and I plugged it in, and I had nothing. And you can see I've got nothing. There's a little power button on the front. Press and hold. I got nothing. Power switch on the back. I got nothing, guys. Yep. So normally what I would do in this case is I would pull out the back and check the fuses, maybe something like that. These guys, because of the motor, since it's a three-phase motor, it normally has motor protection circuitry. And if it's got motor protection circuitry, then that means it probably will not pop those fuses on the back. That's more for like a short circuit or something like that. So let's go ahead and let's take a look, man. Hey guys, Riley, Ashley, thank you guys. That's so awesome that you guys are tuned in. Like I said, this is going to be a more common thing. So it's just something that I just wanted to do. Plus, it encouraged me to clean this workbench. I haven't seen the surfaces of the workbench in probably about a year since I built it. So this is what it is. What you got, Riley? Let me know. I'm gonna try and find a Phillips screwdriver. I see there's two fasteners on this front faceplate. Just to let you guys know, these guys are designed to be taken apart. They are serviceable in the field sometimes. So this whole front on almost all these units will come off. So normally there's fasteners on the bottom, but I got two Phillips right here, and I bet you I can pull this guy right off. What you got, Riley? I'm looking. Oh, sorry. Come here. Oh, come here. Oh. Sorry, guys. My dog is sitting here at my feet because she wants to be part of this. All right, there's one. I don't know if you guys use these, but little magnetic parts trays. I use them all the time, even though a lot of fasteners for medical equipment are stainless steel and they're non-magnetic. That's all right. All right, that's the two fasteners. Oh, look at that. Just comes right off, lifts off. And the length of the fasteners, oh, here we go. Length of the cables is just right. I'm gonna put the lid down so it doesn't hit me. Look at that. It's almost like it was designed to happen that way, right? Only thing I had to disconnect is your grounding strap, which you can see it wasn't on there very good. So that's something I gotta fix right now. I guess I should be mindful that it's still plugged in. So this guy is live. I highly doubt that the camera picked it up. The reason I'm not going to the AC input plate on the back and checking it from there is because I noticed that there's a slight flashing right here on the power button. It's just a real quick flash. Let's see if it can happen again. Right there, it just did it. So that's telling me that the power supply is probably the issue, because if this guy's flashing, that means I definitely have AC power. it's probably the DC side that's got a problem, because the display right here, this guy right here being lit up, that's all off your DC power bus. So you got the AC comes in, it gets converted to DC in your power supply, which you can see right here. And let's see what else we got. Ooh, well, that's interesting. That didn't take very long. There is, what is that, a thermistor? There's a thermal resistor. So guys, there is something very interesting that's going on right here. I'll go over that in just a minute. It's a thermistor, I think. What you got, Riley? You associate's degree a must? There are actually lots and lots of programs that are coming out for biomed. And guys, it is such a misnomer that people think that you have to have a biomed school to be a biomed. That is definitely not true. At my hospital, we have people called electronics technicians, which they have just some technical background. Some of them might be mechanics or something, and they are doing biomed work. And some of them, one of them, lucky guy, he was just converted over to a Biomed 1. So now he's starting his biomed career. But before, he was an electronics technician. And those guys will usually work on like the nurse call system. They will work on things like, sometimes beds, sometimes the TVs in the rooms, the integrated room TVs. But electronics technicians, and they work right alongside us. You know, they like to think of themselves as biomeds, but you know, they do get to work on some of our stuff for sure. So but yeah, that's a misnomer. People don't necessarily need an associate's degree, even though a lot of times they say that in order to fill out the job application. It's not necessarily required. And if anything, just check that box that says, yes, I have that degree, and let the people that do the hiring figure it out. You know, some of these people have lots of technical background. Some of them have lots of experience, and it translates over. It really does. ITT Tech, I've definitely seen that. I've seen DevRai. I've seen University of Maryland. I've seen lots of these online schools that do it. You know something? I actually have a lot of people that have OJT and on the job training, and that's how they're biomeds, and they're actually good biomeds. I've got some people that I know that are biomeds right now, and they have done anesthesia tech. Man, I've got an anesthesia tech I work with right now. I've asked multiple people if they would help me in enlisting them into biomed, because this guy runs the show for anesthesia tech. And if you guys don't know, if you have a good anesthesia tech, they will save your life. It's amazing, especially if you do surgery. Bad anesthesia techs just ruin your life. And the guy that I've got, he's very interested. He comes in every once in a while to what used to be my team in my shop. If you guys don't know, unfortunately, I was pulled from my position as an operating room team leader, and now I'm doing laboratories, which I don't know. I consider a lot of laboratory stuff Biomed 1, Biomed 2 stuff. But yeah, that's a long story, guys. I don't know if y'all want me to tell that, but yeah, I was pulled from my position, and I've been doing operating rooms for like 15 plus years, and now all of a sudden I'm doing laboratories. But anyway, yeah, please go ahead on the job training. It's some of the best people I've ever had as biomeds were prior anesthesia techs, prior nurses, and these guys, they can rock the job better than some biomeds that come out of, you know, a two-year degree school. But when in doubt, honestly, if you guys have the time to invest, the better training is going to get you just a better job, and they're going to set you so far up for success later. And I'm talking about CBET. No, I know, because I've taken some of the courses there, and I've gone through the enlistment process, and I know, guys, that's a whole other thing. Oh man, if you guys only knew how stressful my current job is. I had to stop my studies with CBET, the College of Biomedical Equipment Technology, and I put them on hold. They put my file on hold for a while because while this whole COVID thing's going on, man, a lot of us are just being run thin, and that's all there is to it. But yeah, cbet.edu, that's the ones. And those guys actually, it's going to take time because it's a real program and it's a lot of in depth. So make some time, and you're going to have to sit down and go through your studies like a real college. And I would say because CBET is champion the whole secondary school for biomedical studies, they're becoming like the standard, and they do have math. And I actually have one of their math books right here on my desktop still because I like to reference it. Believe it or not, there's Biomeds. We're going to use a lot of math and stuff that a lot of people think about. But even today, I'll tell you guys for a fact, today I had to explain to a doctor, and she was a world-renowned microbiologist. I had to explain to her how electricity works in her room because she had 2 lab analyzers, and she wanted them swapped from one side of the room to the other. And then she was panicking on what would be able to work on what circuit. And the lab analyzers were hooked up through a super UPS. It's like a UPS with a battery supplement. And I had to educate her on how many amps the equipment says it draws on the back versus what a standard outlet is in a hospital, which is 20 amps is standard. And she was worried because they weren't red outlets. And I told her it shouldn't matter because with the battery backup system she's got, you're going to have a few hours worth of runtime. And unless you're going through a hurricane or something, I mean, trust me, I don't know. Maybe she's going to need to run those lab results in the middle of the night or something. But you got a couple hours runtime off those UPS systems. So anyway, yeah, it's a real school, and they've got a lot of math, but it's math that I think is applicable to the job. And things like what I had to explain today, going over electrical current and, doing the math of, 120 volts, 20 amp, you got 8 amp on this device. You got a fume hood that's got a 15 amp breaker. So obviously you can't add it to that one because, I mean, if it's got a 15 amp breaker, it means it potentially could draw 15 amps. But I can go on and on. I don't want to bore you all to death, but yeah, it's every single day. You never know what you're going to run into. So we do run into math. And also, I don't know if you guys are familiar with spreadsheets yet. Get familiar with spreadsheets, man. And I make a lot of my templates off of Google Drive, and I run templates off of there. But spreadsheets, man. I'm just thinking in the back of my head, I gotta create a spreadsheet for this month's PMs, and I'm going to go through and I'm going to scan barcodes because I was going through all these different laboratories today, and geez, I was so frustrated because I'm flipping through sheets of paper. Guys, this is 2020. What are we doing with sheets of paper? But that's the way I'm currently doing it because that's the way that it was, presented to us from my management, my contracted management. So anyway, guys, let me get back. Let's see if I can show you all what's going on here. Let's see, we'll just detach. All right. Okay, guys. Yeah, this is my workshop, and you can see I got hopefully my dog's right there chilling with me. I want to show you guys something. So this is a power supply right here. All right. And you can see that your AC power comes in, and it is live right now. I'm aware of that. So right here is where your AC power comes in. It goes through some filters, and check this guy out right here. This is your bridge rectifier. Okay. Now you guys should get to know your components. All right. If anything, just your generic components. I'll tell you another quick story. Today, I had a Biomed bring to me a infrared light source. And this infrared light source, it would, when I turn it up one direction, it would turn on, and then I flip it over and it would go off. And I was really confused. I should have just stopped and looked into it and checked. But instead, I took a cover off because I was trying to figure out what was disconnected inside. And as soon as I took the cover off, I seen the photodiode. And it's just one of those things. If I wouldn't have recognized the component of photodiode, then I would have continued pulling it apart. But as soon as I seen the photodiode, I just kind of had one of those, oh, so stupid moments. Because what I was doing is when I flip it up, it was sensing the lights and it was shutting off the infrared light. And when I turned it upside down, then it would turn on and I seen the infrared light. So I was chasing my tail for a little bit, but I got saved because I recognized the component on a board. So guys, back to this little doohickey. All right, let's see if I can get this up and out of the way. Mind you, it is still hot, so. All right, so this right here is my bridge rectifier. And you always know a bridge rectifier because they're large, flat, fat things, and they have posts coming out of them. But you can kind of see how the AC power comes through. We got some filters, and look at this guy right here. I don't know. Look. Can the camera pick it up? You see that debris that's on top of this guy? This guy right here is called a thermal resistor or a thermistor. And what happens is this acts as a natural current limiter for the entire system. So when it senses heat from these components right here, this guy increases the resistance, which limits the current for the rest of the board. It's like natural short circuit protection. And I don't know if you guys noticed it, but there's a hole in the top of this little guy. So if you look over by the leg, you see the little brown stuff coming out right there? There's a hole in it. Now there's two things that you can do in this instance. I mean, one of the things I can do is I can short that guy with the jumper and then turn it on. But because, you know, this is America, I'm going to obviously just order a replacement board. But any of you guys over in other countries, hint, hint, you could just desolder that thermal resistor and solder another one in, and you're probably good to go. So that's it. I want to point out a few other things to you guys. See all these guys right here? See these three and these three? These are your motor drivers. They operate in pairs for these. All right. And this guy right here, you see this wire that comes out of the bottom? Those wires come over here. I don't know if you can see it. See that round thing back there? Let's see if it can get it. I can barely see it. That is your brake resistor, that guy back there. So what happens is when you tell it to stop, it will throw current into that braking resistor, and well, it slows down your three-phase motor. But you're always going to find that braking resistor in there someplace. So that's just another piece of the anatomy of one of these centrifuges. Let's see what else we got. Right here, you see this little pull cord. This is a manual pull cord that comes out the bottom. It's hidden on the bottom, so that in case the power ever goes out, they need to get their samples out. They just pull on this guy. See that? It's motor actuated, so they pull this guy down, and it manually opens the lid so they can get their samples out, because that would be devastating if you had samples that you spun up and this guy blew a fuse or something, you couldn't get back in there. Some of these samples are extremely critical, so they can get their samples out in a timely manner before they go bad. Oh, let's see what else we got. Okay, so this is all obviously low voltage, my control board, my power button. But I'm guessing, if I really wanted to go further into it, that I've got no power right here at my bridge rectifier because my thermal resistor right there is just popped. So I'm going to order a replacement board. This guy's going to get put back together, and it's going to go back to work with me. Yeah, I took my work home. I do that sometimes. If I really want to deep dive into a failure and figure out what the heck's going on with it, because if it happens to one, it's probably going to happen to others. I got some other stuff to show you guys. Hold on. Man. Yeah, that's very true. Yes, you are the jack of all trades. They're expecting you to know how to do stainless steel welding. An architect, you're absolutely right. I hope you guys can read plans, because I have been in on several construction projects, and I've even found where they were expecting to mount monitors on the wall, but they had no routed video or networking on that wall. So they couldn't put the computer there. They couldn't put a video monitor up there because they had no electrical planned in the initial plans. And if they don't plan it, then they didn't budget for it. And the circuit panel wasn't designed for it. So you can actually have huge add-ons. They're called addendums to your construction projects if you don't plan things correctly. So that's why it's always nice when they're doing a construction project that they kind of key us in. Hopefully every shop has got a Biomed that's somewhat capable of reading plans and improving things, because it does happen, guys. It definitely happens. Oh man. Electrical engineering tech. That's interesting. I can definitely tell you guys. Matthew, you are so correct. PMs can be boring. But one of the good things about PMs is it teaches you a hell of a lot about your equipment. Even though I've got just centrifuges and freezers and refrigerators and stuff, I'll tell you right now, I went through probably what, 6 or 7, 8 different types of centrifuges, just regular centrifuges, not even like refrigerated centrifuges or anything. So because I did all these PMs on this equipment, now I know how to control it. I know how to stop it. I know certain ones you have to shut off in order to get it to reset, so you can turn down the speed. Some of these, man, here's something that you guys should know. Centrifuges, it is not always in RPM, or revolutions per minute. Sometimes they're in RCF or in something else. They're often called RCF. It's not RPMs. RCF is like it's a formula based on the amount of centrifugal force that unit can generate. So there's things that are going to affect that, like your speed, the sample size is going to affect it, and your distance from your center point. So on a smaller centrifuge, it has to spin way faster in order to obtain the same amount of RCF as a larger centrifuge. And this one here, this guy goes up to, was it 4,500 RPMs? It's not too much for, a little guy like this. I got some centrifuges that are about that big. They go 14,000 RPMs. And I can tell you guys for sure, when those guys wind up, I am standing back a little bit, because centrifugal force is just a monster. When something goes wrong, like your rotor splits up or whatnot, man, you can tell like a little bomb goes off inside this guy. And I have had that. There's a couple other things I want to talk with you guys about. I know centrifuges are boring, right? So there's one huge thing that I remembered, and I want to bring up to you guys right now, okay? When you go into an area and you work on somebody's equipment, especially laboratory equipment, guys, write down the settings that the user had it on when you walked up to it, okay? That means the amount of minutes and the RCF or the RPMs. Write it down before you touch anything, because these guys, unfortunately, do not reset themselves often when you shut the power off. Like I shut the power off on this and I had it at 4,500 RPMs. You turn it back on, guess what? It wants to sit at 4,500 RPMs. And the users, they're not stupid, but users are users, man. Users want to walk up to a device that they've been using every single day. They want to hit the start button and walk away, especially in a laboratory. So always, always return the unit to the exact same settings that the user had when you walked up to it. And normally in like surgical, only on the old surgery devices would they remember your last settings. But on laboratory, it seems like every stupid device I walk up to remembers the last setting. So I usually start at the maximum, which this one, it's like 4,500 RPMs. and I work down like 35, 25, 1500. But if I leave it at 1500 RPMs and they're expecting 4400 RPMs at like 5 minutes, their sample could be ruined. It could be ruined because of something I did. And yeah, I could deny it. I could be like, hey, you guys should check your settings on your equipment. But that's not realistic. So always return your settings to exactly the way the users had it, okay? Because these things, it's just a miracle. Old OR equipment always would remember the last setting that you had it at. If you shut the power off, you bring it back up, it would be exactly where you left off. And if you can imagine how that could go wrong, let's say you start testing an ESU at like 5 watts or 10 watts, and then you start going all the way up to like 300 watts, and then you shut it off and you go do something else. Well, they turn it on and they're expecting it to be, and you're shooting 300 watts. Use the device that's been in their room for years, maybe. They just walk up to it, they press a button, they walk away. So it's up to us to remember the settings that they had. It's the first line. When I walk up to a laboratory item, it's the first line I write on my PM sheet, like what the settings were, and then I proceed with the PM from there. So yeah, PMs are boring, but it's taught me a lot of stuff that I haven't done in a long time. I mean, that's for sure. So you're remodeling 6 ORs. Man, I'll tell you what, that's a project. We just built 30 ORs this year, and that's why I took over as the team lead for the operating room. And then they added on all the rest of the ORs because we could handle the job, and it was over 70 at the very end, and they're not even done yet, so they were going to add more. Oh my gosh, that's crazy. How do you test in G's? RCF. Man, I wish I could explain to you what RCF really is, but I know that RCF is it's a formula based on the circumference of your rotor, or the diameter of your rotor, and the speed. So it's some theoretical number, and I don't know how you get to it. Let me finish putting this back together so I can get it off my healing bench here, all right? Oh, man. I'm getting so caught up. Guys, I hope I'm not boring you guys off from talking too much, because this is exactly, man, I had like I had some rum, and man, I'll tell you, I've had a rough week. So I was ready to just go home and chill. But there's so much stuff that I wanted to talk to you guys about, and it kind of helped me vent a little bit, because there's some crazy stuff that's going on at my work. Crazy stuff. And yeah, I just need to come out my workshop and chill a little bit. And because I wanted to explore this guy, I brought him home with me. So I got all my tools here. Some of the guys see me carrying out my tools, and I think they think that I was leaving permanently, because I don't know if you guys can see it, but this guy right here, I have all my tools from upstairs in my operating rooms. Yeah, you can see I've got a dolly right there, and it's stacked up to here with boxes, and those are my tools. And I had everything, man. I did it all. And the only thing that sucks is when I get these special projects at work now with laboratory, and I don't have like my soldering station, I don't have my microscope set up. God, it's so frustrating. A lot of the consumables, like my dual layer tube and stuff, that was all my personal stuff, and it's all right over there. It's packed. All right, let's get this guy off the bench, because I got some other interesting stuff. Oh yeah, centrifuges are so heavy, guys. These things are crazy heavy. Oh my gosh, guys, I want to talk to you all about meters. Let me get out a couple of my meters. I got a few of them here. All right. And let's see, what's the last way? Anyway, I'll just leave this one here. I actually had to whip out my portable oscilloscope today because of that whole infrared light source that I was telling you guys about. Because the infrared light source ran off of like 24 volts AC. So in order to see, let's say, a voltage sag or something like that, or let's say there was some feedback on your AC, I needed this guy. Because for whatever reason, the technician that brought me the light source was saying it wasn't working correctly. And it ran off of a 24 volt AC power supply. So I showed him how we can check the waveform that comes out of it using my little oscilloscope here. But that brings me to one other thing. I had to show another technician the correct way to wind his meter leads on his meter, okay? There is a correct way because, guys, I tell you all the time that the weakest part on every single thing that's got a cord is where the cord, the soft piece, meets the rigid piece, all right? So this is my meter that I use here at home. Man, I got so many meters. It's kind of crazy. So let's say I want to take this meter and put it in its bag because I bag all my meters constantly. What I normally see people do is they take the leads like this, bend them off to the side and wrap it. All right. I see that so common. And anybody that's been fixing things for a while knows that your meters are going to eventually break right here and right here. All right. That's a horrible idea. Do not wrap your meter that way. This is straight out of the bag. Straight out of the bag. All right. I'm bringing it over to show you guys. Do you see how I turn my meter leads up? I turn them up just like this. This releases all the strain points. So I flip them around so that they're facing up, and then I wind them like so, very loosely around the meter, so that my meter leads are now sitting off to the side, kind of like that, right? And then it goes back in its bag, and it goes in there nicely. See, just like that. It goes in its bag, it gets zipped up. I can throw it around, and I don't have to worry about bending those meter leads over. I see so many technicians that wrap the shit right out of their meter leads. This is not the way to do it, guys. So, like this one, because the orientation of these leads, you can see what I did is I turned them so that they're going across the body of the meter, so that the strain relief is right here in the middle. It's not at the edge, because when it's at the edge, that's when you break your leads, guys. Look at that. And then I always just bend the meter leads so that they're up. And here they go in their box. It's so simple, guys. We got to take care of our test equipment. This stuff is crazy expensive. That meter that I had over there, that's like $700-800 without the options, and with the options that I've got, like the Bluetooth voltage reading and stuff, that's like $900, man. And so, like, we got to take care of our stuff. One of the things I want to show you guys with this meter right here, my portable oscilloscope. This guy's awesome, but notice one thing, a very important thing. The oscilloscope probe is not connected to it when it goes in storage, because the same thing. These guys right here, your BNC connector, this is actually kind of flimsy. It's got a nice strain relief on there, but it's very flimsy. And every time I see these things go bad, it's either right here because they wrapped it too tight like that, or it's right here. So you can see what I do. I just loop it loosely, and it goes into its own pocket, just like this. So nothing is being strained, and it goes pack out system. Guys, I love this system. I wish already they had the drawers out. The drawers are going to be here the first quarter of 2021. When those drawers come out, it's going to be a game changer, you guys. And I don't know if you've seen it. I'm going to have one probably maybe tomorrow. Maybe I'll do one tomorrow. I'm going to go to the store and I'm going to try and find the Milwaukee Pack Out vacuum cleaner. They've got one that's slender and it fits right into the cleats. All right. And it's quiet. Oh my gosh. There's YouTube videos out there that show you how quiet this thing is, and it runs off battery. The same as my DeWalt. Now, I like these DeWalt's so much that I have one here at my house. I use it to clean up the CNC machine because things like my baby, so I keep it very clean. But it's battery-powered vacuum. I mean, what's not to like? Well, the one thing I don't like is it's kind of bulky, and it doesn't fit on my Milwaukee pack-out system. So I have to use a strap and strap down every single time, and that's getting a little old. So tomorrow I'm going to go investigate the Milwaukee system, and I'm going to see if I can buy one of those vacuums. Game changer, guys. It's so quiet, battery-powered, everything I love. I'm going to show you guys what I've been up to. My house is extremely decorated for Christmas right now, guys. I'm serious about this holiday. And unfortunately, one of my Despicable Me minions, it died. And I did my best to keep him alive. You can see right here, I took its initial power supply, I ripped it off, I put another one on there. This guy right here, it's pulse width modulated, speed controlled, and this guy just is dead. And it's not worth it. It's only like, what, $30, $35 for a new replacement. But I did my best. I put in a 12-volt power supply, and I have it so that it's, you know, it screws in. Just like a normal one. I usually win. Instead of Christmas cards this year, guys, I am using this CNC back here, and I am cutting out a whole bunch of these baby Yodas out of hardboard. And hardboard, let's see, I got some right here. Look at this. Hardboard is this extremely durable material, and it's really easy to machine. So I designed this guy right here, and I cut it out, and it got painted. And this is going to get mailed out instead of like family photos or anything like that. I'm going to mail out baby Yodas. Because that's like the best part of 2020 so far, isn't it? I mean, I don't know about you guys, but this year has been a little bit of a doozy. So I got that going on. And I'm going to show you guys a secret. Okay? Oh my gosh. I could wrap them long ways and put them in the probe holders, but then you have pokey things coming out the side of your meter, and that would just get annoying. I mean, you're going to whip your meter out, just undo the leads real quick, do your check, put it back up, put it back in the bag, and press on. Oh man, some guys don't even bag their meters, and I get it. I use my meters a lot, extremely a lot. And I still put them back in the bag every time. And look, and that meter was like brand new still, and I've used it for years. So it does matter if you keep them clean and keep them put away. Do I have a patient simulator? Oh man, I've got all sorts of patient simulators. Remember that you have technically patient simulators on your, let's see, your defib analyzers. You've got them on your NIBP analyzers. I mean, every single analyzer has some sort of patient sim built into it, at least for like EKG, ECG rhythms. There's a bunch of different types of patient simulators, but hardboard, Riley. I said hardboard, H-A-R-D, hardboard. It's very, very hard. I mean, that's just one piece. I've got, let's see. You can see I was trying to engrave something for my daughter. This is dry erase board. And the dry erase board, you can engrave images in it, and the kids can color it. And when they're bored, you just wipe it off, and they can color it again. You know, how many times can you color a unicorn? A lot. Trust me, my daughter knows. This is something I want to share with you guys. Man, all you guys that work in hospitals, maybe you want to check on this. Keep it in a kit someplace, because you never know, man. This is a pneumatic tourniquet cuff. And after these things get used, hospitals just throw them out, or they try and recycle them, whatever. But you can use them to test your pneumatic tourniquets. Sometimes you'll just find them laying on the ground. You know, somebody opened up a package, whatever. You've been in this game long enough, you'll get your hands on one. But you can see I've got one of the ports plugged off completely right here. And when you extend it, this guy becomes a very powerful tool. I've got it hooked up to a squeeze bulb and a little pressure relief, a little T right there. And this guy, it's got a metal sleeve on the inside. You can feel it. It's very durable. And what you do is, let's say you need to get into your car, okay? Traditional, how could I say it? Traditional methods for getting in a car involves driving a wedge in between your door frame and your car frame. And that's where you will damage your paint or your weather stripping every single time. With this guy, it's got like a knife edge here. Obviously, I would cut this ribbon off, but it's very, very blunt, okay? And you can shove this in between your door frame, and then you just inflate it. To inflate it, this will blow into a sphere, and it is, think of hydraulic energy. There's so much energy to a pneumatic sleeve that it will separate the door frame effortlessly so that you can get a tool down in there to unlock your doors. Now, I kept one of these for a long, long time, sometimes to lift up equipment. Let's say that some equipment's really heavy and you got to get something underneath it. This will do it. This will rip a door off the hinge, I swear. Behind one of these pneumatic sleeves. See? And this is just a small one. Some of these are much larger than this. So it's a very stiff apparatus. And when you want to release it, just open up the T-valve, and it will almost go back into its own storage. See that? I keep one of these in my Jeep because I'm crazy like that. And you never know when somebody's locked their keys out of their car. Something like this, you can get in there. It creates no damage whatsoever on the car, the door, the paint, the weather stripping. And such an excellent tool. You know, we have access to this stuff, guys. Squeeze bulb, T-fitting. Anyway. Oh my gosh, guys. I hope you all have a very happy Thanksgiving. Man, I'm so ready. I think I'm doing the cooking this year because that's just the way it is. So I'm going to wake up nice and early, going to smoke me some turkeys. And guys, I hope that you guys enjoy this holiday. I'll be back to work on Friday because I don't think anybody else is going to be there. And I got all these PMs to do. Guys, I got so many PMs. I got like 300 and some PMs. And I just took over this account like 2 weeks ago. It's not very fair, but that's life. And that's Biomed life, right? So why are staff scared to test monitoring on themselves? Well, I don't know. That's a good question. Why is it that staff, when you tell them, have you done proper pad preparation, they always say yes. Skin prep. If there's one thing I can tell you guys as junior biomeds, skin prep is everything, man. Skin prep. Which means if you got geriatric patients or you got some people with certain skin diseases, you got to do skin prep, which is there's a little abrasive pad that you use to scratch off the external dermis, which is your skin, and it leaves a fresh layer underneath. And there's also like a gel that you can put on there. So skin prep, geriatric patients, old people, they will have dry skin, and you will get so many ECG, EKG anomalies. You'll get artifacts, you'll get leads off, all sorts of stuff. It's almost always skin prep, guys. Back down our ECG. They say, did you change out the pads? And they say, yes, we did. Then you get there, no, they didn't. Oh my gosh. Are most PMs infusion pumps? Oh, Jesus, no. I have no infusion pumps. Larger hospitals do not do infusion pump. For most of the biomeds out there, you're not going to be doing infusion pumps. It's going to be some sort of special team, or it's going to be contracted out. And this is most large facilities, at least the ones I've been to. They always have like a pump team, or they have some hired side entity like Agility or something like that that's going to be doing your pumps. And they're talking about like throwing pumps back towards our way, and it's like, man, guys, I'm not looking forward to that at all. So that's very, very stressful. I got plenty of work already, man. Sterile processing equipment. What type of sterile processing equipment do you want to know about? You want to know about sterilizers, plasma sterilizers? Do you want to know about steam sterilizers? There's, vacuum sterilizers. I mean, there's all sorts of different types of sterilizers, man. Scope washers. I mean, I could go all day about sterile processing equipment, and yeah, it can be disgusting. It can be labor intensive. It can be crazy, and often they do contract a lot of that out, especially your larger sterilizers, and especially your plasma sterilizers. Plasma sterilizers are pretty cool. But I do know a third-party company. There's a company called Biomed that's up here in Dallas, and they have people all around the United States. They're the largest third-party entity that will handle and contract out your plasma sterilizers. So pretty crazy stuff. I actually visited their campus, and I wanted to see like what they're really like. And they said that I could record video up there. Given it was my first encounter with them, I thought it was going to be more polite for me not to. But next time I go back, guys, I'm telling you, I'm going to get some video of what these guys are doing. It's amazing stuff. So, oh my gosh, you guys, can you believe it? Oh my gosh, it's 2 years later, and I've got 2,700 people that are subscribed to this channel, and that's only like 30 to 40% of my viewer base. 2,700 people, and I've got shout outs from all countries all around the world, man. This channel has had more support than I ever imagined, because if you ever like pay attention to like welding videos or something, you'll get nothing but welders tearing down other welders' work. It's a bunch of measuring contests between people. And that's just crazy. It's just crazy. Biomed, it has been just amazing. I've been corrected a few times here and there, but guys, if you don't know, like most of my videos are just completely ad lib. This stuff is often not about it on the ride home or something like that, but I'm not like reading from like the YouTube videos that most of you guys see. This stuff isn't scripted, man. I'm just shooting off the top of my head, and I might edit out some things later after the fact, but I just do the best I can with what I know, because I just want to say what I got to say, and then, let you guys return to your day, man. But yeah, this is just crazy that I've gotten the support that I have from you guys, man. 2,700 subscribers, and at the rate that I'm going, and I don't know if you guys know this, but my channel just recently, like I would say in the last month or two, it finally got monetized as a real YouTube channel. And now I've got real medical equipment providers that are advertising on this channel. And I don't know if you guys have seen it yet, but that is just insane to me. I've got medical equipment companies that are contacting me through this. And it has been absolutely amazing, because I love talking to people about their technology and about the future. And some of these guys are watching these videos, and I'm just extremely surprised and humbled that some of these people even care what I think about their product. And nobody obviously wants you to badmouth the product, but sometimes people just got to know when, enough's enough and that something's not very good. But man, I'll tell you, this whole entire project is crazy. And I'm extremely humbled that you guys want to even hear what I have to say, because I love what I do. I absolutely love what I do. And I love talking to you guys. I love answering questions. And this is probably the best part of my day. It really is. When I get to think about making these videos throughout the day, I see some really cool stuff. I'd love to show you guys so much stuff, but I can't, because if you guys don't know, my hospital is very, 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 very strict on recording. And because of that, I'm extremely limited on what I can show. And sometimes I have to take like 30 and 40-pound devices home here to my shop just to show you what's going on. And that's because I love what I do. I love sharing some of the stuff with you guys, and I'm going to continue doing it, man. No matter what, even if that means I have to go to a new job, that doesn't matter to me. I'm going to continue doing this for y'all. Every service school was story time. What's the dumbest thing you've seen staff do? Oh my gosh, guys. I actually have a photo of it. I wish I could share it. It's on one of these drives here. There was a piece of paper that was on a defib, all right? And it said, do not use this defib. It said, see if I can get it correct. They say that it's importing ECG results from a patient over in some ward across from the hospital. And the person, I do believe, was serious. I think that they think that whatever the arrhythmia was, how did that happen? But they think that it was pulling settings from a patient someplace else in the hospital. And so they put a do not use, and I took a photo of it. I got a photo here someplace. Because if you think that your defib isn't showing you the arrhythmias that your patient's going through, you're probably killing your patient. I'm just going to say that once, man. It's insane. But man, yeah, HIPAA laws. Well, you know, the thing is, guys, I don't know if you know this, but I've been extremely careful on what I show you guys. In fact, I've made it a point not to point out who I work for. I'm sure some of you guys probably figured it out over time. But even my LinkedIn profile, like I went through and I deleted who I currently am working for, because I've had people, because of these videos, reach out to the HR department at my hospital and try and get me fired because of something I said online. And I don't even think I'm saying stuff that's all that controversial. I mean, I'm just saying what's really going on. You know, I try not to get political or anything at work, or definitely not on this channel. I mean, I don't think it belongs here. You know, you guys want to hear, you know, what's going on in our world in medical equipment repair. You guys want to hear some stories about some crazy, stupid stuff? Oh, man, I got stories every day. I definitely do, man. I'll tell you, one of the stupidest things I've seen is I have seen where a doctor was taping down a surgical table to the floor because the brakes were not working correctly. Taping it down. I'm talking like a whole roll of tape plus, you know, just taping across the shield at the bottom, taping it to the floor. Taping a surgical table to the ground, man. It's crazy. I've had users take neuro microscopes that have like tape on them that say do not use this item. Take the tape off the screen and put it in service, and then when the doctor powers up the neuro microscope, it crashes right on the lockout tagout systems, guys. I am a firm believer that every biomed shop needs to have a lockout tagout system, a kit with, you know, a regular binder, and hardly any shops do. It's real sad. If I were to go up to any biomed generally and say, hey, I want you to lock this device out, most people either couldn't do it or they wouldn't know where to record what was locked out. And that's a real shame, because I'm a firm believer that it should be part of our competencies as a biomed. But anyway, guys, how's my hospital dealing with COVID? Man, I can tell you just in general that in general, my hospital is doing a very good job with a lot of things. The one area that I would say has always been not good is, you would think that a device that comes from a COVID room would have like a sticker or a tag on it, so you know that this device is a COVID device. Let's say a ventilator. Let's just take a ventilator. I know for a fact they're taking these devices out of these rooms and they're hardly wiping them down. Luckily, COVID isn't as bad as it could be. I mean, it could be worse. But anyway, guys, I think I'm going to let you all go. It's almost an hour on here. Man, I could just talk all night, y'all, especially if I were to drink any more rum. I think this would turn into show because I just start going off on some stuff. But I do hope you guys enjoy this holiday tomorrow, and all you guys that are coming from other countries, I hope that you all can take a moment and just think about what's happened this year and be thankful for the people in your lives, because I know I am, and I'm extremely thankful despite all the weird stuff that's been going on lately. I'm extremely thankful for you guys. I'm thankful for my support and the people that have backed me up. I am so the biomeds that I've encountered throughout my career. You guys that have helped set me up to where I am today. This is insane. I mean, I go and I talk to people from back in my hometown. I grew up in some small town in Michigan, and I talked to a lot of people back there, and a lot of those people are still back there. And here I've traveled around the world. I'm working at one of the biggest hospitals here in the country, just craziness. And I'm extremely appreciative of all the people in my life that have got me here. So, and that would make all of you guys part of that, okay? I am doing the CBET as far as the 2-year degree, okay? So I'll definitely go into that with some more detail soon. But yeah, that's a whole long story. But I'm telling you right now, look into it, cbet.edu. And they have an excellent program. You just got to have the time to do it. And guys, I don't have the time to do that right now. I mean, between my family, you know, my kids are homeschooled right now, as a lot of you guys as kids. And it's like a job after a job, you know, plus I'm doing all this stuff as hobbies. So I'm going to leave you guys at that, man. Thank you all for tuning in. You guys, enjoy your day and enjoy the rest of this week, man. We're going into the holiday season. We need this right now, okay? We really do, because I'm stretched thin, like mentally and physically. I know a lot of you guys are too. So y'all have a good night, have a good Thanksgiving, and I'm gonna put up a video again very soon. Maybe we're gonna do this again, because this was very fun. It was a good relaxation for me, okay? All right, y'all, have a very good night, okay?